is are we doing it the best way? And we can certainly look at that, to make sure we're doing it the best way. An example that, Jarno and I talked about and we looked at a little bit is, concurrency or memory locations. Are you using contiguous locations? And I think you are. We didn't see any red flags there. It all looked good as far as, how you try and manipulate your data in contiguous fashions in memory. But that's only one of the bullets that you can look at. Another one is network latency. Are you talking to a cloud somewhere, or are there other potential areas of latency that could impact the performance? And then, if we've exhausted all this and we're all confident that we've done everything that we can do here, then it's time to look, okay, are there ways of improving the algorithm? But certainly, looking at changing the algorithm is, in my suggestion, is certainly not at the top of the list. That is difficult. It's difficult to change the algorithm. I think there's a lot more we can be doing to optimize the performance before we go there.
All right.
And sorry. Yes.
Yeah. So Jesse and Josh, they have to go because there's another meeting now.
Yeah. Okay. Well, this slide is the backbone of the optimization. There's more, so it's all right. I just wanted to say here that we're looking for the hot spots. That's where we should start. The fragmentation of the memory, the network, latency that we talked about. But it's the bottom line is that if you want to improve the code, it's really hard to do if we can't measure anything. So we need to measure something. So there's an axiom out there. You maybe heard about this, and it's a good way to kind of convince yourself, yeah, there must be something we can do. 90% of your code is executed 90% of the time to execute is in 10% of your code. I'm not saying this is your case, but this is, an axiom out there that makes you want to think, hey, maybe this is not so bad. Maybe there is an area we can focus on. And how do we do that? We can start with a profiler. And this is what a profiler does for you. This is your code, the FTTD code, run through a profiler. And what it's basically telling us is, DFT update function runs 72% of your time. And within that function, you've got another another bunch of functions in there, and each one is about 13%. So, okay, wow, now, I've got an area now to look at. Like, what is this function? Let's go in there. Let's go take a look, okay? Now, I'm not saying we should swear by profilers. They do have drawbacks, but at least, they will give you some idea where to start in this in this venture. So here's what we found. So as I mentioned, DFT update, it's actually more than 71% of the execution times. Then there's other functions that are about 12% under this guy. And then, like I said, okay, it's a good place to start. But the problem with profilers is that, they don't tell you everything about wall clock time. In other words, if the program needs to go or if there's a system call or waiting on a system event, like an operating system event, the profiler may not take that time into consideration. So it's not profilers are not the ultimate tool, but they give you a good idea. And one way to be able to use profilers and get better data is to look at the frequency that a function is being called. So the more you structure your program into functions, and we look at how often those functions are called, it could give us an idea about, whether or not those functions are contributing to a high wall clock time. So, it boils back down to structuring, the code, as we talked already, into smaller functions. And it's not just about a good coding practice, so it's more readable. It's also going to help you get more data out of your code by making smaller functions, so you can figure out how to optimize the performance. Breaking the code into functions is something I was going to touch on in the next workshop. I thought that would be a good time, to start talking about that. So just some thoughts on optimization. Some of the, earlier I talked about memory allocation and computation. There are patterns out there that are used in programs that, take care of special types of operations. There's the pre-computation side of things, lazy computation, meaning, do we have to compute all our data, or can we just compute some of our data and do the heavy computing on another subset of data? There's batching, caching. I mean, there's all these patterns that we can look at and see, are we doing this in the existing code? And if we're not, does it apply? And if it doesn't apply, fine. But, we might find something, hey, maybe it does apply here, or maybe it's worth investigating because we could get some significant benefit out of it. So, this is all coding practices. It's a little more, but it's not algorithmic changes. It's really just changing how you do things.